the defense and aerospace business, component manufacturers and system integrators are always balancing functionality and cost. Today's DNA application requirements are pushing the established envelopes of complexity and performance. High-end application environments like mission computers with high-resolution digital maps, electronic warfare, and radar and sonar are all demanding more bandwidth, more I/O, and higher speed signaling and switching. With that in mind, a group of leading manufacturers got together in 2004 and introduced a solution that addresses these D&A market pressures. Known as the VITA 46, the new standard promises to provide high-speed signals for both serial switch fabrics and high-speed I/O, as well as legacy VME or PCI protocols for a variety of commercial and military systems. I'm Joe Aragona with the Business Report. In May 2005, CurtissWright Controls Embedded Computing announced its first single-board computers and multi-DSP engines based on the new VITA 46 standard. A few months later, CurtissWright continues to lead the VITA 46 charge by building industry momentum around VITA 46. Earlier, I spoke to Stewart Dewar about the company's VITA 46 offering. Stewart is the company's single-board computer product manager and chairman of the VITA 46 Standard Body Committee.
CurtissWright will introduce products, new products in our classic product streams, which include single-board computers, digital signal processors, and chassis. Our first product in the single-board computer area will be our 185 Power PC base. It'll have 2 XMC sites. It'll feature both PCI Express and Serial Rapid I/O backplane connectivity. Okay. Then we'll bring forth our Champ 6 quad multiprocessor card, which will feature also a combination of PCI Express and Serial Rapid I/O backplane connectivity, and then a chassis to house up to 8 conduction-cooled VPX modules.
I asked Stewart what the new VITA 46 product from CurtissWright Controls meant for his customers.
It means they get a lot more I/O capability, almost twice what they can get today with a VME 64X class card. All I/O pins are multi-gigabit capable, up to 6.25 gigabits per second. And with the auxiliary VITA 48 standard for new mechanical formats, they have the option for significantly more power dissipation per slot.
Stewart explained how this new VITA 46-based product has been received by customers.
Very favorably. They see these new product offerings and the standard as being a very natural evolution of VME technology. They see it solving problems that are fundamental and need to be solved, particularly the adoption of modern switch fabrics like PCI Express, advanced switching interconnect, Serial Rapid I/O, InfiniBand, etc., and they've been very receptive.
Stewart says the standard was approved at the working group level in January, and that there is a new name associated with the standard.
The VPX standard was approved at the working group level in January 2006 and has been now submitted to ANSI for formal ratification at that level. We've enjoyed tremendous participation in the working group from a wide variety of companies, including what I like to call our cooperative group, including Mercury Computer Systems, Radstone, Spectrum Signal Processing. We've had tremendous support from Tyco, who are the connector manufacturer, and we've had customer representation, including Boeing and Northrop Grumman in the group as well.
While Curtiss-Wright works to bring its new VITA 46 product to market, there are still questions in the industry about why a new standard is necessary.
And the VITA 46 standard really came about because a number of the vendors in the industry recognized in order to build future larger, higher performance systems that we had to solve some of the basic problems that were resonant in the existing standards. And it wasn't necessarily that they weren't capable of supporting the current technologies, it's the future technologies that we look forward to in terms of the new serial interconnect standards that are coming out, the serial connectivity of high-speed I/O capabilities that are there. So these are the main 2 key drivers. We have higher density of electronics and miniaturization of electronics that resulted in our ability to put much more functionality on a board, which drives the I/O capacity of the board. So it's really that high-speed connectivity, the fabric connections. We have current technologies, for example, like Star Fabric, that work very well in the current compact PCI and VME world. Those connectors are very capable of handling the speeds that Star Fabric supports today. But it's looking forward that we see we need to move that farther into the future in terms of the enhancements that are coming out. And the biggest change in VITA 46 is the connectorization. It really is the ability to support much higher bandwidths. Star Fabric today is a gigabyte per second. We're talking about 8 to 10 gigabytes per second in terms of fabric connectivity. If you think of the types of applications in terms of sensor processing, high definition TV standards that are all digital interconnect, these are all the standards that the types of functionality that we want to support, and that serial interconnect speeds that we need to achieve in the 5 to 10 gigahertz level are supported.
John explained that the VITA 46 standard is only part of the solution. The connector is one of the key enablers.
Right, and to talk about 5 to 10 gigahertz performance at the connector level, it was really the connectors, in this case developed by Tyco. It's called the RT2 connector, and it supports a wafer style that allows us to have a very controlled impedance across the signal interconnect from the backplane to the board. That gives us the high speed performance. It also gives us high density, because you can put a lot of these connectors in a small space on the backplane where we're constrained in a 6U and a 3U backplane slot. So it gives us lots of connectivity, and that translates to the type of performance that we're looking for in terms of future systems.
More and more our customers are looking to interconnect their high performance systems with fiber optic cable on the aircraft and on the military vehicles. They offer lightweight, they're EMI proof, and very high data rates. As the use of this technology grows, they want to take those fiber optic signals directly to the module inside the chassis and not have to have a fiber to copper converter at the chassis wall.
With all these changes that VITA 46 is bringing to market, my question to John was, is this a revolutionary new standard, or is it evolutionary?
And one of the conscious elements of VITA 46 standardization was to support backward compatibility, as well as I say, looking forward to the future with these new fabrics and interconnects. So the consideration in the standard was to support a heterogeneous type of backplane so that we could allow customers who have existing modules and VME form factors or compact PCI form factors to be able to interoperate with the future modules of the VITA 46 standard. So electrically we have connectorization for VME in the actual connectors on the backplane, and at the same time we have the ability to have the high-speed fabrics to support the tremendous amount of bandwidth improvements that we expect as the future interconnect fabrics are deployed.
The 6U form factor has been used extensively in the industry for over 20 years now. It's very widely adopted. People are very familiar with it. For the most part, people are very happy with it as a nice, natural format for building electronic systems. So we obviously have to continue to support that. The 3U format is seen as more of a market opening opportunity. There is 3U formats in use today, somewhat a selective market. We feel that the I/O density of the VPX format will truly enable the 3U to cover a broader spectrum of requirements.
One of the things I wanted to know was what the serial fabric on the backplane meant for customers.
It means that our customers can take advantage of new serial fabric standards like Serial Rapid I/O, PCI Express, InfiniBand, and Advanced Switching Interconnect that are used and standardized in the broader IT community. So they can take advantage of these low-cost, standardized components and ultimately do more for lower cost.
And logistics is a key enabler that we've considered in the VITA 46 standard as well. And that was really driven by the military's desire or recognition for the tremendous cost involved in maintaining their systems. Their general approach has always been a 3-level maintenance approach. And what that translates to is at a first level, which is at the flight line, say on a carrier ship, you actually replace the complete box when there's a fault detected. That means that on the carrier you have to have these additional replacement boxes. These take up a lot of space. Then the next step is bring that box back to an intermediate level depot where the modules are determined as which module is faulty. The module is then sent back to the third level, which is actually the original equipment manufacturer. The concept going forward is that's too expensive. We need to look at ways to shrink that to 2 levels to replace that need for that intermediate level, which means that you have to replace the modules right at the flight line. Some of our customers, our systems integrators, have talked about the tremendous savings that could offer. Something up to 40% of the total ownership cost of the system could be accommodated by supporting a 2-level maintenance. Yeah, and VITA 46, again, we've had a lot of our customers involved in the process. Some of the big integrators have basically highlighted to us to be able to support two-level maintenance, we need to consider the things that are relevant at the flight line especially. It's a nasty environment, it's not a lab environment, lots of salt, sand, dust, electrostatic discharge from handling. So part of the consideration of VITA 46 standard is to support the idea of covers on the module. The actual connector, and this is one of the innovations in the Tyco connector, it supports ESD protection right in the connector so that now we have a complete system at a module level that allows us to consider the concept of replacing a module at the flight line and not damaging the module, being able to survive in that type of environment.
You will see Curtiss-Wright continue to evolve our classic product lines into this new VPX format. First of all, with the 185 single board computer, which will use the next generation PowerPC chip, have 2 XMC mezzanine sites, have advanced switching interconnect backplane connectivity. We'll also, in parallel, be developing our CHAMP 6 quad multiprocessor board, which will feature serial rapid I/O backplane connectivity, and then a chassis to house up to 8 conduction-cooled VPX modules. They will be applied to the classic range of systems that Curtiss-Wright has built its business around over the last 10 to 15 years. Fighter aircraft, tactical military vehicles, that sort of thing.
The VITA 46 standard represents a convergence of many outstanding ideas around the next generation of VME. It addresses both the 6U and 3U form factors, the latter of which is becoming more important as integrated components enable system sizes to shrink. No other VITA standard has brought high-speed signaling support to the 3U form factor. By explicitly including deployed military environments, the VITA 46 standard addresses important issues such as stress testing, vibration testing, and compatibility with conduction cooling techniques. It appears that Curtiss-Wright is once again taking a leading role in shaping the future of the embedded defense and aerospace market. For the Business Report, I'm Joe Aragona.